Wow, it's been a long time I spoke, and I'm already nervous just standing on this stage. How do I use it? All right. Can everyone hear me clearly? So today I'll just be talking about SLOs. This is a buzzword right now in the site reliability space. And today I just want us to understand why this is like a buzzword and why a lot of companies are moving towards adopting this fully. All right, so a quick introduction. My name is Manasseh. I am an SRE at Zapier. So Zapier is a company that helps you automate your workflows. Our goal at Zapier is to make sure even the developers and the non-developers are able to automate their workflows easily. Like you can set up like a workflow to automate once you get an email, you want to send an SMS to someone, you can do that with automation using Zapier and a lot of other automations at Zapier. So I work at Zapier with a lot of other engineers, and we're a distributed team across all the globe, all over the world, and yeah, it's actually a very nice place to be. So, okay. All right, so before I just start, I want to understand how many people here are DevOps engineers in this hall right now? DevOps engineers. All right, cool. How many people here are software engineers? Okay. Product managers. We don't have any. Site reliability engineers. All right, cool. So this talk is going to incorporate a lot of DevOps terminologies. That was what I was asking. So I'll try as much as possible to make sure we all follow along, like while I'm giving the talk. All right, so before I just proceed, I just want us to understand one of the key things when it comes to reliability. So reliability of a system, as you all know, is we are trying to make sure that the system is available anytime you want to access the system. Anytime you want to talk to the system, you can send a request and you get a response back. The system is secured. So you want the system to perform as you want it to perform. But how do you know that your system is reliable, right? That is where this question comes into play. You will not understand how, but we'll get there like very soon. So I have this simple question. Who do you think, how many people here watch football? I believe everybody here watches football. So who do you think is the best DM in the Premier League, right? That's the question everybody like asks around. Is it Rodri? Is it Casemiro? Is it Declan Rice? So I have people saying it is Rodri. Some people say it's Casemiro. Some people would argue, if you're an Arsenal fan, you might argue that the best DM is Declan Rice, right? So yeah, like everybody has who they think is the best DM, right? But how do you measure this? How do you know who the actual best DM is? So there is only one way you can measure something in reliability. You can measure the reliability of something. As a footballer, as a DM, as a striker, I need to know what you're good at. I need to look at your metrics. What is that thing that makes you better than another person? So this is like these are like links, right, to different to the player statistics. I hope I think. So these are all links to the different player statistics. And if you open the link right now, I was supposed to have my system here so I can open the link and show us like the different statistics. But yeah, if you can just help me open the links, if there's a network connection. All right. So we can't open the link right now, but basically, if you open the links on these individual pages, it will show you things like, all right, Casemiro has won 71% of his tackles. Rodri has like 71% passing accuracy. Declan Rice has like the highest ball carries. So these are all metrics. All these are metrics that tells you how efficient a player is when it comes to a particular aspect of his game. So that is the same thing with systems. When you have a system, the only way you can know how reliable that system is via the system metrics. That is just what it is. So if I have a system and I tell you, all right, how reliable is your system? First bank. So when I tell someone that, all right, my API is 99% available, what does that mean? You get my point. So what does that mean? My API is 99% available. What does that mean exactly? You need concrete metrics to tell you that this particular system is reliable as such. Some of those metrics are latency. Some of those metrics are latency, availability, error rate, right? So I would say, okay, the overall latency of my system is 100 milliseconds. That means if you access my system at any given point in time, I want to guarantee you that your latency would not be more than 100 milliseconds. So these are the only ways you can actually measure the reliability or the metrics of a system, the efficiency of a system. You only have to use what? Metrics. So metrics here is what gives birth to SLOs. So metrics is what brings forth SLOs. SLOs are a way of measuring your own user satisfaction with your metrics. There was not too long ago when the whole Naira crisis was happening, when we had issues with the new currencies, some banks were malfunctioning, right? You go on and then you see people complaining, UBA is shit, GTB is shit. You get, so these are different, sorry? All right, so UBA is shit, GTB is shit. People just complain about different banking systems and they say these banks are all shit. These are what? User satisfaction. So the only way you can actually measure your own user satisfaction is by defining something called an SLO. And we'll get into like how exactly we can do this for our individual users. So when we measure, when a survey was carried out, I think this is 2022, by HubSpot. And based on that survey, the number one cause of user loss in a company is product quality. So when you lose a customer, there's a higher chance that that customer left your product, not because they found other cheaper softwares, but because your product quality was shit. So that is like the major fact when user switch to another product. So, for example, me personally, I used to use UBA before, but after a while, I switched to First Bank and OPay because OPay was very reliable, and we all know that OPay is reliable. So when your users don't get the satisfaction that they are looking for, there's a higher chance that they would move to another platform. And that is like the major thing. That's the major reason why we want to look at SLOs. So you cannot look at SLOs without understanding SLIs, right? So SLIs means service level indicators. So SLIs are metrics that define your system. That is just it. So SLI is something like, if you have like a web service, your SLI is going to be something like your latency, your error rate, your throughput. If you have like a storage system, like if your service is something like an S3 bucket, you're operating an S3 bucket, your SLIs could be something like your data freshness, your write rate. So practically, SLIs are just anything that you can use to know how your system is performing internally. You get? So the SLIs of a player right now, as we just looked at, the SLI of a particular defensive midfielder is how fast does he win the ball back, how good is he in the air. So all these are indicators that tell you how exactly this particular footballer performs. So once you are able to establish your SLIs, you can now use these SLIs to judge the quality of your own system. And that is where you define things called SLOs. So one major mistake people do when trying to understand the behavior of their system is they look at the behavior of the system from the developer's perspective. That is the number one mistake people make when trying to define your service level indicators. So for example, I'm building a web service, right? And then I'm trying to measure how fast does this service connect to the database. The user doesn't care about that. The user is not interested in how fast your system writes to the DB. He's not interested in how fast your cache loads or how accurate your cache is. What the user is interested in is something that he can feel, is something that he can relate to. You get? So that is why you need to define your SLIs from the user's perspective. So if I'm operating a bank service, for example, some of the user SLIs I might define is the number of successful transactions, because that is something that the user is interested in. So if I have, let's say, Netflix right now, Netflix is going to give you an SLI, something like, okay, I want to, how fast, or that's like the latency of their service. You don't want to be watching Netflix and then it's just buffering up and down. You don't want the user to wait while like it buffers for long. So if you are defining your SLIs, you have to define it from the perspective, from the lens of the user, not from the lens of you, the admin. You as the admin, you can have your internal metrics to measure your system, but when trying to measure how efficient it is with respect to the user, you have to look at it from the user's lens. So that is something we should all be aware of. So the question now is, what do our users care about? Right? What do our users care about? These are just different use cases. So users don't care about CPU usage. You cannot say, okay, we had this incident because the CPU usage was high. The users don't care about that. They don't care about your memory usage. They don't care about your network traffic. They don't care about your database query time. All they care about is that your service is what you say your service is. Right? So if I have a user-facing system, the user is interested in how available is the system. If I access the system at this time, will it be up? If I access the system at this time, is it down? So that is what the user is interested in, number one. I think availability is like one of the most important things for users, right? If I'm making a transaction, is it going to go through? I like to use banking applications because that is like where most users have issues. In Nigeria, we all relate to that because all of us have different bank accounts. So the users are interested in like what they feel. So for example, for a pipeline, if for a CI/CD pipeline, as developers, we all use different CI/CD pipelines. We are interested in, okay, if I start this pipeline right now, how long does it take for the build job to start? If you go to GitHub Actions and then it takes like 10 minutes before the job even starts, you have to look for another different CI alternative because that is not reliable. So that is some of the metrics you should be looking at from the lens of the user's eye. So the next question becomes, how do I choose SLOs? So SLIs are service level indicators, and SLOs here are service level objectives. So an SLO is a value, is a metric that defines your user satisfaction, right? So if I say something like, I want 95% of my users I want my users to know that my service is available 95% of the time. That is something that you want to guarantee to your users. It means every moment in time, and at every point in time, if I access your service, I am guaranteed that it will be up 95% of the time. That is a value that you need to try and maintain. And you choose these values based on what you know is attainable to you. So if I'm building a new service and I know, okay, I haven't met all the metrics, I haven't met all I haven't satisfied all my high availability requirements, I will not go ahead and say, okay, I want to set an SLO for 99.999. So 99.999 basically transmits to something like 4 minutes a year. Out of 365 days a year, my service will be available almost throughout the entire year. But I want to tell you that it's going to be down for at most 4 minutes. That is not something that is attainable for most of us. You need to understand how available your system is before you set that value that you want to guarantee to your users that, okay, this is the value I'm guaranteeing to you that my service will be available for. So in choosing SLOs, the first thing is you need to be optimistic, right? You know what your developers can do. You know what your system can do. So an SLO is a target for you as a developer, for you as a system admin. You want your service to be available for some number of minutes, like in a day. You don't want to go and over-assume. You don't want to be too optimistic. We all want to get where Amazon and Google are, where their system is available for 99.99% of the time. but we don't have the capacity for that. Those systems like that, they have like redundancies, they have high availability scale-ups. So for example, you can see maybe something like S3 is redundant across like 5 different regions. Your system is only running on one zone, and you are setting your SLO to be 99.99. It's not ideal. So first things first, you need to understand what exactly is it you can do first, and then choose that, and then use that to define what your SLO will be. And then the second one is, you need to define few SLOs for your service. So what this means is, you don't want to set too many SLOs. You don't want to target too many things. So if I'm starting a new service, one thing Google recommends is set 3 SLOs. It means choose three key metrics, right? The first metric might be availability, latency, and throughput. And stick to these 3 metrics first. Then as the service matures, you can eventually choose to increase the number of SLOs you want to define for that metric. Or for that particular service, sorry. So don't have too many SLOs. Don't have too many SLOs. Choose 3 to 5. 3 to 5 is actually the recommended. So for every of your service, choose 3 to 5 metrics, and then use those metrics to define your user interaction, your user experience on that particular service. The other one is keep it simple. Don't create SLOs that are complex. SLOs should be straight to the point. I want my users to understand that my system is going to be available. I want my users to understand that the latency of my service will be this. I want my users to understand that the throughput of my service is this. Don't create an SLO that is too complex to understand for both you and both for your own users. And then the last one is, SLOs is like, choosing SLO is a continuous thing. So you have to start and then you keep refining it. Today, you define your SLOs as 90%, but as time goes on, you realize that, okay, all right, my service is no longer is more available than 90%. It means I have to increase my SLO to something else. So, all right, let's move it up to 95%. As the year runs out, you are like, okay, we are in a stable place. Let's move this up to 99%. And then we define it as time goes on. You keep refining your SLOs. And the same thing happens if you realize that your service is not as available as you want it to be based on other factors, you drop your SLOs. You drop it to a value that you know that you can maintain. The whole purpose of SLO is to know that this is what I can maintain. You don't want to define something that is too ambitious that will put a stress on both you and your team. So yeah, the earlier talk here talked about platform as a service, right? One thing about SLOs is they don't just need to be about customer-facing services. They can be for internal tooling. So at Zapier, we have our own platform as a service. The developers interact with the platform, and then we use the platform to set up like the service, the other tooling around it. And the thing is, we also have SLOs for those services. And for those services, the customers are our users. That's the users, they are the developers in the company. So your SLOs don't have to only be for external services like your user services, your major service that people access. It can be for just things that are within the company. And then you set that, and then you use the SLOs to make sure that your users within the company are satisfied with what they are getting. All right, so this is where it begins to become a little bit more interesting. Why SLO is important is because it introduces this concept called an error budget. It introduces a concept called an error budget. What is an error budget? An error budget is like the opposite of your SLO. So if my SLO is 99%, that means I have an error budget of 1%, right? What does that mean? That means that, let me just break it down in simple terms. An error budget tells you how many minutes you are allowed to have a downtime before you breach that particular SLO. So if I have a bank service, I like using banks because they've done me shaky. So if I have a bank service and I say, okay, my SLO is 99, I want to make sure that the SLO of this particular bank service is 99%. And the errors start increasing. We start having downtime. And I measure the downtime, and the downtime tells me, all right, if this error continues, the service reliability will drop below 99%. It means I'm exhausting my error budget. So the error budget is like that allowance that allowance within which you can you can introduce problems, you can introduce bugs into your system. Once that particular allowance is exhausted, your users are no longer satisfied. That is why SLOs are important. It allows you to make this have this kill switch. So I know that once my errors are not up to, once my error budget has not been exhausted, it means my users are still enjoying my service. But once my error budget has been exhausted, it means my users are beginning to feel the impact of my system, and then I might lose customers. So that is why error budgets are important when it comes to SLOs. So I've been talking about the 99%, 95% availability and all that. 99.99% availability means in a single day, you are allowed to have only 14 minutes of errors on your system. So out of 24 hours, you are allowed to have 14 minutes of errors in your system. So if I work with this in mind, if I set the SLO of my system to 99.99%, it means once I get to 14 minutes in my system, and there are errors within 14 minutes, I have breached my SLOs. And then that thing now means that my users are no longer satisfied with the outcome of my service. So at that point, I need to try my best to make sure that I have resolved that particular error. So 99.99% is too much for most people to attain. That's why you can define it based on your own system, based on what you can maintain as a company. So yeah, another interesting thing about the error budget is it influences what you can do and what you cannot do as a developer. So when your system is continually down and you keep releasing new features, there is a likelihood that the new features will keep on introducing new problems. So what do I mean by that? Your users are already complaining that your current software is buggy. It is not a time for you to release new features. It is a time for you to stop your release and then try to fix the critical bugs that are in your existing systems. So that is how the error budget influences your SDLC. So once your error budget has been exhausted, it means you are no longer allowed to introduce new features into your system. That's what the error budget means. So once your error budget is exhausted, it means you cannot introduce new features into your system. Rather, you are advised to use that time to fix critical bugs only. Because introducing new features means you're introducing a new unknown into the system, and new unknowns can bring in newer errors and then make you fall lower into your SLO budget. So once you introduce these particular SLOs and you are trying to maintain your error budget and the error budget gets exhausted, stop your software release process and instead focus on critical bug fixes only. And that is where most startups fail. Most startups don't measure their error budget. They keep releasing new features. They always tell you, as a startup, you are supposed to go fast. But the problem is, going too fast, introducing new bugs, as you're introducing new bugs, your customers are leaving you. They are going to other alternatives. And why? Because the reliability of your system can no longer be guaranteed. So if you measure this particular error rate in your system, and you know that, okay, I've exhausted my error budget, I need to stop, focus on fixing new features, and then allow, there's something called recovering in the SLO, like recovering your error budget. So your error budget can only recover if there are no longer errors on your system. I will get to how we can measure this in like coming slides, but you allow your error budget to recover. So within those periods while your error budget is recovering, you are not allowed to make any other new changes into your system. And by doing that, you try to ensure that your users are satisfied. So that is why error budgets are very, very important in your system. So yeah, as I was saying, this is just a further explanation into what I already said. This particular meme is practically what users want. So who are we? We are the customers. What do we want? We don't know. When do we want it? We want it now. So your users don't actually know what they want. You have to tell them what they think they want, right? So the user says they want a login feature. You give them a login feature. They want a registration feature. You give them a registration feature. If you collapse the registration and the login feature into one modal or into one form, some users will tell you that they like it, some will tell you that they don't like it, right? So it is up to you to choose what you will release to the users and what you will not release to the users. So that's practically what this particular thing just tells you. So since you are in charge of releasing your features, it is best for you to choose when to release them to make sure that you maximize your user satisfaction. So when your error budget is expired, don't try to release new features. Just try to focus on ensuring the reliability of the existing features. So this is practically like the next step of implementing your SLOs. One thing you should always do is to alert when your SLOs are burning, when your error budget is burning. So I don't know, different people have different monitoring setups. Some people use Grafana, Grafana and Prometheus. Some people use Datadog, different method of monitoring. But the major thing is you should always alert when your SLOs are burning, when your budgets are burning. You need to understand when there is an error in your system that you need to address. That's one thing with SLOs. When you define your SLOs properly, it enables you to discover new errors in your system, because how you define your SLOs, the metric you use to define your SLOs will tell you how the user is feeling. So if that metric is telling you that there is a problem, it means you need to check it out. And as your error budget is burning, you need to always ensure that, okay, I have an alert that tells me when my error budget is about to expire so that I can act on it. If it is something that I can act on, I act on. If it is something that we need to revisit, we revisit it, and then we lower our SLO accordingly. So based on how you want to measure your error budget, you can define different alerts. So for example, you can say, okay, if 2% of my SLO is exhausted in 1 hour, give me an alert. If 5% of my SLO is exhausted in 6 hours, give me another alert. If 10% of SLO is exhausted in 3 days, give me an alert. So different alerts can be defined in different ways to let you know that there is a problem in your system that needs addressing, and there's a problem in your SLOs that you need to address immediately. And if you don't have these alerts, you will just have an SLO without action, because you have an SLO, but you don't know when it is expiring, you don't know when the budgets are expiring, and you don't know, like, you don't have like proper visibility into the SLOs that you have earlier defined. SLOs can help you catch your problems in time, all right? So one of the major things that to create your SLO, you need to create an SLO. You need to first create an SLI. So that is how that thing works. So your SLI, for example, is your latency. As we've earlier said, your latency, your transactions, your successful transactions per minute, your throughput. So if, for example, you've defined that 95% of your transactions per minute, no other errors in any part of the system, the SLOs are telling you that something is wrong somewhere. You need to go out and figure that shit out. So that happens a lot, because we've seen this several times in the company, that we have an SLO defined. The SLO is telling us that there is a problem, but no other monitoring system is telling us that there is a problem. So it means we need to go back to the drawing board, look at the monitoring stack we have, and then try to figure out what exactly we need to improve in our monitoring. That's why SLOs are important, because if the users are experiencing something from their own end, even if your systems are not telling you that something is wrong, something is actually wrong somewhere. So that's another important thing about SLOs. So whether you have a proper monitoring stack or not, if you have an SLO, it is going to help you improve that existing monitoring stack. That is one thing. That's another important thing about having SLOs. So how do you implement SLOs? That's the question. How do you implement SLOs? Different people have their own implementations of SLOs. Originally, when we started our own project on SLOs, we first did everything manually. We created our own Prometheus rules for different services. We defined alerts for them individually. But then we realized that there are already existing systems that help with these implementations. And the famous one is Sloth. Sloth is an open source project that works based on an existing Prometheus installation. So if you use Prometheus here, it means you can easily use slot. So if you have if all your services, if all your monitoring and your services are on Prometheus, slot is the way to go forward. If you use Datadog, Datadog has an inbuilt SLO implementation already. So you just need to define the SLI you want Datadog to monitor, and then Datadog would automatically generate the remaining things about that particular SLO for you. These are like the two major ones. Some of these monitoring systems have inbuilt SLOs, like inbuilt, and some of them already have like inbuilt SLO features. But if they don't have it, you have to figure out a way to implement it in your own systems. But on a private note, like personally, I recommend Sloth because Sloth comes with it comes with its own SLO dashboard. So once I create a particular service, it creates the SLO dashboard for me. So from the SLO dashboard, you can monitor how your SLOs are performing. You can monitor how your error budget is burning, and you can also monitor like how other particular SLOs are in that particular system. So yeah, this is practically like a quick overview of the SLOs in the system. In the SRE system, that's in the SRE space. And there's a lot of things you discover like while you go ahead implementing your SLOs. You find out that some SLOs work for you as a company, some don't work for you as a company, and you have to like redefine them to suit your own company needs. You get? So for some people, latency and availability is not the major thing they want to measure. These are not the things that their users are interested in. You will only know this when you go ahead and implement them in your own system. You only know this when you go ahead and try to adapt them into your own system. So in as much as we've spoken about like the different type of SLIs for different systems, you can only experience this and know which one is best for you when you go ahead and then try to adapt them to the systems you all use. So yeah, so go ahead and try to experiment with SLOs and then preach the gospel to your companies to better ensure that your users are satisfied with what you're giving them. Thank you.
Questions?
Yeah. Questions? Yeah.
Thank you, Manasseh.
Yeah, thank you.
Nice presentation. Okay, so my question is around error budget. Okay, so we understand that we have 3 accepted availability system time. We have the 99%, we have the 99.9, and we have the 99.99. Okay, so and in your error budget presentation, you showed us that when a system is available for 99.9%, you have a service downtime, accepted service downtime of just 14 minutes and probably 24 seconds. So in a situation whereby we cannot achieve 99.99, or we cannot even achieve 99.9, we were able to achieve just 99% of system availability. What's the accepted, or how can we calculate rather the accepted downtime for a 99% system availability?
All right, so you want to understand how you can calculate the accepted downtime?
For a 99%.
For 99%.
Yes.
All right, so first things first, I want you to understand is no one is trying to force you to adapt a particular 99% for your own particular system. Internally at Zapier, we have systems whose SLOs are 95%. We have systems whose SLOs are 97%, 98%. So it depends on, like, everything depends on what you can maintain, right? So ideally, your user-facing system should be at least 99%. That's ideal, right? So the calculations for how you can know the downtime is documented in the Google SRE workbook.
Thank you for your presentation. I just wanted to, when you were talking about error budget, I I couldn't help but, picture being the old ops guy who keeps saying no to new releases and all of that. So, and I noticed in your title slide, you're trying to address DevOps, product manager, and SRE, how they work together. Can you speak on what the culture should be like so that you don't become that person who just keeps saying no at every time, because it seems like you're going to break, every new feature is going to break the system, right? But can you speak on the culture that is needed for that?
That's a very nice question. So SLOs are not something you adopt as a team. It has to be something that is agreed with, like it's agreed as a company, right? It has to come from your head of engineering or your director of engineering, and it has to trickle down to like the implementations, like those are implemented at the bottom. So it's not something that you just say as a team, all right, we have these SLOs, or we can no longer deploy, no. So once you have these discussions as an entire company, then you go ahead and implement it, and then when you tell someone, all right, look at the dashboard, it is telling us that we can no longer deploy. They don't have like that question to you, like, why shouldn't we be able to deploy? You get my point? So internally, right, we have gates that block deployment automatically. So once an SLO is breached, the SREs will not even answer you, because if you try to deploy, it will tell you that the SLO of this particular service has been breached, so it can no longer deploy. You get? So it's something that you adopt as a company, not as an independent team. So that is, I hope that answered your question.
Thank you, Manasseh. I'll go back to the error budget. You said for 24, on your slide, I saw that for 24 hours, you have 14 minutes downtime. Would you want to check that? I think that should be like for a year or something.
For a year, or for a year, right? Or for a month?
I think that should be for a year, because I saw 24 hours, 14 minutes. That should be a very big problem, because if you have 14 minutes in one day.
In one day. I think that's right. I think that's right, yeah.
Okay. So my next question again, because when you started, you said that you are a back-end engineer, right?
So
no, I just want to ask a question, because I want to see the impact of DSA, like the structure of your codes when you're writing the program. Although, given the fact that you have redundancy, your storage and everything is okay, what's the impact of the structure of your code, the complexity of the lines of code you write on SLOs?
I don't think I understand that question.
Okay, because why I'm asking this question is because of your background, right? Like a back-end engineer. So given the fact that your cloud services, you have redundancy, everything, reliability and all of that, but then looking at the application itself, the application that you've written, that your team have written, what's the impact of the structure, like the complexity of the code you write? Like, for instance, the big old notations of each code you write, how does it affect SLO now? Oh,
okay. So first things first, that bio, I wrote that bio since 2018-ish. So I'm no longer a backend engineer. I haven't written like a backend code in a while. I am an SRE, a site reliability engineer. But the number of lines you add to your code does not translate to your SLOs, as I was saying earlier. Your SLOs is what your users see, right? So if you're a DevOps engineer, I think I saw you raise your hand, right? Cloud engineer, all right, cool, good. So if you use something like an ingress, you know what an ingress is. So if you use something like an ingress controller on Nginx, right, and the ingress controller routes traffic to a particular service, you get me? If you want to measure the availability of that particular service, one thing you might want to do is measure the number of 500 or 5xx errors that are coming from that particular service from the lens of the Nginx controller. You get my point? So regardless of the number of lines of code you add, what the SLO is interested in is the number of errors that is thrown by that particular service. So you can add one line of code and it introduces a bug that breaks the entire system. You can add 1,000 lines of code and no bug is introduced. You get my point? So there is no direct relationship, there's no correlation between the lines of code you add and how it affects the users. So I hope I was able to answer your question. All right.
Sorry, one more question.
Yeah.
I just want to, because I'm trying to picture, in real life how this thing works.
Yeah. Can I plug this here? Can I project this? Yeah.
Okay, so in a team where you have, DevOps and then SRE, I'm trying to understand as an SRE, what's your part in the tooling, and who sets it? Are you the one that sets it up? Then what is the DevOps person doing, and what part are you setting up? Because from the presentation, most of it you spoke about was, in terms of monitoring. So is it that the DevOps engineer sets up everything for you, and then you are just monitoring and taking action from there?
All right. So first thing you have to understand is, if you listen to the person that spoke before me, he made something clear, right? DevOps is not a title; it's a culture. You get my point. So different companies over the years have adopted different titles for that particular culture. Facebook don't have DevOps; they don't have SREs. They have what we call production engineers, right? So production engineers are people that handle the implementation of these particular cultures in the system, in the company. SREs likewise are the same thing. They are, you can call them DevOps engineers, but the title is just a syntactic sugar to tell you that they are DevOps engineers that are they are more interested in the reliability of systems. So we don't have DevOps engineers. That's what I'm just trying to tell you. We don't have DevOps engineers. We only have SREs. So we as the SREs, we implement the infrastructures. We do the deployment of the SLO infrastructures, and then the users just consume them. That's the developers within the company consume them. Does that answer your question? Thank you very much.